This lesson is 5.3. This is solving trigonometric equations. Now that we know some of those trig identities, we can actually solve trig equations that have a variable in it, like x, if we also use some basic rules from algebra. So for example, isolation is the first method. If I asked you to solve for x and I gave you the equation 2x minus rad 3 equals x, we would know that we could just subtract, we can subtract x, and then add this rad 3, add this rad 3. We would end up with x equals rad 3. Now if I asked you to solve for x in the equation 2 tangent x minus rad 3 equals tangent x, we would do the same thing. First we're going to isolate that x. So we would say minus tangent x plus rad 3, and we get tangent x equals rad 3. We're not quite done because we need an x equals. We're trying to solve for x. So when does tangent x equal rad 3? Well, we could do inverse tan of rad 3, or we could think about our unit circle, right? What are all our values on our unit circle for tangent of x equals rad 3? So let's look at tangent of 0, we get 0. Tangent of pi over 4 we know is 1, because we're talking about our slopes here, and tangent of pi over 2 is infinity. So really the only two left in our first quadrant are pi over 6 and pi over 3. Pi over 3 obviously has a bigger slope. This, if we took our y over our x, we would end up with rad 3. And if we took our y over our x, because that's what tangent is, sine over cosine of pi over 6, we would end up with rad 3 over 3. Well, we already found our rad 3. That happens here at pi over 3. And it's going to happen every n times pi, all the periods that we have. If we added another period, we would end up with another pi over 3. So it's going to happen at x equals pi over 3 plus n times pi, which is our period for tangent. Now let's look at factoring. So the first method was isolation. Next method we're going to talk about is factoring. So it says solve for x on the interval 0 to 2 pi. We're including 0, and we are not including 2 pi. So for factoring, we want to group things that are the same and set the equation equal to 0, right? So if we want to set our equation equal to 0, we need to subtract this 3 cosine x. So we have cosine x times sine x minus 3 cosine x equals 0. And what do we have that's the same within both of these? On this side we have a cosine in common, so we can pull out that cosine and we're left with sine of x minus 3 equals 0. So this equation will be true when either this equals 0 or when this equals 0. Either when cosine x equals 0 or when sine x minus 3 equals 0. That's when our equation will be true. So cosine of x equals 0. When does this happen? Well, again, let's go back to our unit circle. We know here at pi over 2, our cosine, our x value, is 0. So it happens at pi over 2. And it's also going to happen at 3 pi over 2. We only care about, oh my goodness, that was not a 2. We only care about from 0 to 2 pi. So for this x, that's from pi over 2 and 3 pi over 2. Now, when does sine x minus 3 equal 0? That's the same as when does sine x equal 3? For what value of x could we ever get 3? We can't, right? The very largest value we can get is a 1 when we plug in 0 or negative pi or something like that. So our only answers are pi over 2 and 3 pi over 2 on the interval 0 to 2 pi. The final method we're going to talk about is using our trig identities. So this is from section 5.1. You can go back and watch those videos if you need a refresher. We're given complete each of the following steps to solve 2 sine squared x plus cosine x equals 1 in the interval 0 to 2 pi, including both. So we have this sine squared x business. So what I'm thinking we're probably going to use is the Pythagorean identity, which is shown in there. So let's first write the original equation like it asks us to do. So we have 2 sine squared x plus cosine x equals 1. Next, we want to substitute using the Pythagorean identity. You can feel free to go back and look at those, but the Pythagorean identity we know is cosine squared plus sine squared equals 1, and you can rewrite this as anything. We have a sine squared, so we would say 1 minus cosine squared. If we remove that cosine to the other side, is equal to our sine squared. I left off the theta there, or the x, but it's included, it's assumed. So if we did that here, we would get 2 times 1 minus cosine squared x plus cosine x equals 1. Next, we want to use the distributive property. Obviously, we're distributing this 2, so we get 2 minus 2 cosine squared x plus cosine x equals 1. Next, you're going to subtract 1 from each side. We're basically isolating that x value. So if we subtract that 1 from each side, I apologize. We are subtracting 1, which means we are going to have our equation compared to 0 because we're going to factor it. So we have now negative 2 cosine squared x plus cosine x plus 1 equals 0. And then we want to multiply everything by negative 1. So we get 2 cosine squared x minus cosine x minus 1 equals 0. And that allows us to factor. We can now factor this equation. So we get 2 cosine x plus 1 and cosine x minus 1 equals 0. So now we just need to see when does 2 cosine x plus 1 equal 0 and when does cosine x minus 1 equal 0. Well, this one is saying when does cosine x equal negative 1/2. That's from here. And when does cosine x minus 1 or cosine x equal positive 1. Well, these values happen at x equals 0, x equals 2 pi over 3, and x equals 4 pi over 3. That's your answer. So this is using trig identities to solve.